Hey everyone, and thanks for tuning in again. In today's video, we'll be going over diagnostic plots. So we covered some of these diagnostic plots already in the checking regression assumptions video. We looked at scatter plots as well as histograms. However, that video was more conceptual and focused on how to identify violations to assumptions that are testable in our sample data. Now that we're familiar with what violations might look like in plots, this video lays out a practical approach for using plots as a diagnostic tool. What I'll show you in this video is a concise set of plots which give you the biggest bang for your buck. This approach is easy to implement in your data analysis workflow and should work well for any regression analysis as well as other analyses that are extensions of regression. For example, there's structural equation modeling, multi-level modeling, and factor analysis. As mentioned in class, remember that all assumptions are likely to be violated to some degree, especially in sample data. However, it is unreasonable to try to fix every single violation, and that shouldn't be the point. Many of us have lives and cannot spend an unlimited amount of time checking that assumptions are met or addressing assumptions that are violated. So a more reasonable goal is to provide evidence that the assumptions are not too badly violated or passable, and therefore the results of the analysis are likely to be unaffected. So there are two things. If there are no severe assumption violations, then you are able to proceed with running the analysis and interpreting the results as usual. But if there are severe assumption violations or evidence of severe violations to assumptions, then more work needs to be done, but at least it's clear where your efforts should be focused. So with that, let's go ahead and get started with the lab. Alright, so here I have SPSS open. And so the first thing we want to do is go ahead and import our data set. So I'll go to File, if it will let me, here we go. Go to File, Open, Data, and then remember that on my personal machine, I put all of my data sets on the C drive in the datasets folder, and today we'll be working with Reg Data 3. Alright, so go ahead and drag it onto the screen here, along with our output window. Okay. And then just remember that our variables here, the numbers are meant to correspond to which model each variable is in. So x1 and y1 are the predictor and criterion for model 1. x2 and y2 are the predictor and criterion for model 2. And then y3 is just an extra criterion that does not have a corresponding predictor. Okay. So let's go ahead and get into our first diagnostic plot, which will be a scatter plot matrix with histograms on the diagonal. So we'll go to Legacy Dialogues, click on Scatter/dot, and then we'll want to select Matrix Scatter. We'll click Define, and then if you hold Shift and click all the way down to the last variable here, we can put all of these variables in the matrix variables box, and then we can go ahead and click OK. Alright, I'm going to go ahead and make this plot larger. Okay, so here we just have our typical scatter plot matrix, one that we've created before. So to add our histograms on the diagonal, we'll double click here to activate. Our chart editor will pop up, and then under options, we can click show charts in diagonal. And then so for properties, I'll go ahead and make the fill this red color, or this red, actually I'll make it orange. click apply. Alright, I guess that doesn't want to happen here. Okay. Oh, okay. So I'm not going to change the color. And then the charts in the diagonal, we just want histograms, not the normal curve, but histograms. We'll go ahead and close. And then the last thing that I'll change here, these dots are a bit large and it's obscuring a little bit the shapes here, so I'm going to go ahead and double click here on the dots. I'm going to click on marker. I'll leave it as a circle, but I want the fill to be black. And then I want the size to be a bit smaller, so I'm going to make it a 4. Go ahead and click apply, and then I'll close. And then I can close the chart editor, and these changes will be applied to the chart in my output viewer. Alright, so here we have it. The scatter plot matrix with histograms on the diagonal. So it's read much like a correlation matrix. So wherever a variable meets itself, x1 and then x1, that's the histogram, x2 and x2, another histogram. So along the diagonal we have all of the univariate histograms for each variable. And then on the op diagonal, here's the lower triangle, and then remember that this upper triangle is just a reflection of the lower triangle, so this is redundant information, so we could just focus down here. And then on the lower triangle we have our scatter plots. And so what we're looking for here is just anything that that might be indicative of a violation to an assumption. So for example, if we look at x1 and y1, let's see. Sorry, if we look at y1 and x1, so y1 here and x1 here, which is this scatter plot here, we can see that we have somewhat of a megaphone shape here, which, as we've described before, is evidence for heteroscedasticity, because the variability in y seems to increase as x increases. So here at lower values of x, the distribution of, or the variability in y seems to be a little bit more tightly clustered, so it seems to be less. But the variability in y toward higher values of x seems to be a little bit larger, where values of y are more spread out. Again, this creates a megaphone shape, which again is indicative of heteroscedasticity or a violation of homoscedasticity. So this is something that we want to take note of here as we move forward with our analysis. And then now looking at the univariate histograms, we can see that x2 looks to be pretty normally distributed. y2 seems to be pretty normally distributed, although this outlying point out here is creating somewhat of a positive skew. y1 and y3 are a little bit more obviously positively skewed, so those are things that we should take note of. And then I think the worst of them all is probably x1 here, which does not resemble a normal distribution at all, and could even be labeled or described as bimodal. That's a bit of a stretch though, but it's obvious that this is probably the furthest away from normally distributed. So that's something that we want to take note of. Alright, so this plot is probably the one that will give you the most bang for your buck. It takes a lot of information and condenses it into one figure, which is really nice. I'm going to go ahead and show two more plots that we can make to check diagnostics for our assumptions here. So these will be residual plots, and before we are able to plot those scatter plots, we'll need to estimate a model to obtain our predicted values as well as our residuals. So we'll start by going back to our data set, go to Analyze, And under regression, we'll select linear. And then for this example, we'll be looking at the model that predicts y1 from x1. So for our dependent variable, we have y1. And then our independent variable, we have x1. And now to collect our predicted values and our residuals, we'll go to Save. And then I want the unstandardized predicted values as well as the unstandardized residuals. And remember that this will add both our predicted values and residuals to our data set. So I'll click Continue, and then I can go ahead and run the regression analysis. Okay. So here are the results of our regression analysis. We're not really worried about that at the moment for this lab. We just want to obtain our plots of the residuals. But real quick, if we go to our data set, as you can see, we have our predicted values and our residual values for the model predicting y1 from x1. But these have been now added to our data set here. All right. Now we want to plot. So we'll go to Graphs, Legacy Dialogues, and we'll go to Scatter Dot. But this time we just want a simple scatter, and we'll go ahead and define that. And the first plot we're going to look at is we're going to plot our residuals on the y-axis, and then we're going to plot the raw values of our predictor on the x-axis. Go ahead and click OK. And so here we have our first scatter plot with residuals on the y-axis and then raw values of our predictor on the x-axis. And as we can see, there's some evidence here for heteroscedasticity with this megaphone shape again. Okay, so this is somewhat of a simpler plot to get a better idea or to get a better view of assumption violations. We can go ahead and plot our residuals against our predicted values. So go to Graphs, and under Legacy Dialogues, we'll click Scatter Dot again. Just make sure that Simple Scatter is selected, and then we'll go ahead and define. Now what I'm going to do here is I'm just going to pop out x1 and replace it with the predicted values. Go ahead and click OK. And then here we have our plot with the residuals on the y-axis and the predicted values on the x-axis. Now again, this first one up here with the raw values of x1, this is a simpler plot, but in the case here with one predictor, which is a simple case, these actually give the same plot. Because of the scaling of the variables, this one is a bit more stretched out, whereas this one's a little bit more compressed, but this is the same scatter plot. But when you're moving into more complex models, plotting the predicted values against the residuals may give better insight into assumption violations. So that's just something to keep in mind. Okay, so what we've done here is we've created our first plot, which is probably the one that will give you the most information. And it's our scatter plot with the histograms on the diagonal. And then we followed up with some residual plots here. The first one plotting the raw values of the predictor against the residuals, and then the second one plotting the predicted values that come from our model that is predicting x1 or predicting y1 from x1. We take the predicted values from that model and then we plot them against the residuals. And with that, that concludes this video on diagnostic plots in SPSS.